Hello ladies and gentlemen, welcome back to our online distance learning Algebra 2 here with Mr. Hagedorn. Today our lesson 9.4, evaluate trigonometric functions of any angle. So when we take a look at what we're doing for today we're going to get more into what happens if it's just an angle that's found somewhere on the coordinate plane. And with that, what we have to remember is that everything is going to reference back to theta. So it says, let theta be an angle in standard position, and let x and y be the point where the terminal side of theta intersects the circle x squared plus y squared equals r squared, which is the Pythagorean theorem. It says the six trigonometric functions of theta then are defined as follows. And I've listed those all out for you in reference to those three parts, x, y, and r. So if we keep those in mind, those six trigonometric functions are also known as circular functions. And very specifically, as you're going to see here in a little bit, we're going to talk about them in the setting of the unit circle. Okay? So let's say that the point that we're going to be going through is negative 815, and the angle is in standard position. What would the six trigonometric functions be? Well, in that case, ladies and gentlemen, before we can do anything, what we need to do is we need to figure out what is the other measure. So we know that x is negative 8. We know that y is 15. So if we use the Pythagorean theorem, then that would tell me that r is equal to the square root of negative 8 squared plus 15 squared, which if we do our math there, we end up with r equaling 17. So at this point, it's just a matter of filling in the blanks of what we just talked about in our notes. So in this case, if we go right down the line, we'd have the sine of theta, which is y over r, would be equal to 15/17. The cosine of theta would be equal to negative 8/17, and the tangent of theta would be equal to negative 15/8. The other trigonometric values, remember, are the reciprocals of these. So the cosecant of theta would be equal to 17/15. The secant of theta would be equal to negative 17/8, and the cotangent of theta would be equal to negative 8/15. So again, that's using the point that the terminal side goes through, and we found the length of r, or the length of our radius in that circle, at 17 using the Pythagorean theorem. So now what I'd like to take a look at here is take a look at a little bit of what are quadrantal angles and what's the unit circle. First of all, the quadrantal angles are the angles that come up and land right on the x or y axis for the terminal side. So the quadrantal angles are 90 degrees, which is also 1/2 pi radians, 180 degrees, or pi radians, 270 degrees, or 3/2 pi radians, and the last one would be 360 degrees, or 2 pi radians. On the flip side of that, we would also have 0 degrees, which would be 0 pi radians. Now the unit circle is exactly what we just talked about on the previous screen, but in this case, instead of r being some value, r is always going to be 1. So with our angle, the vertex of our angle is still always going to be found right at the origin, and we'll have a radius of 1. The values of sine of theta and cosine of theta then are simply the y coordinate and the x coordinate respectively of whatever point you happen to be going through. So if you take a look here, the sine of theta, which was equal to y over r, if r is 1, then the sine of theta is y. And the cosine of theta was x over r. With r being 1, that simply leaves us with x. So if we take a look at using this unit circle, and using the understanding that everything on that unit circle from the center out for r is 1, we can evaluate the 6 trigonometric functions of theta being pi over, or 3/2 pi radians. So in this case, if we think about it by starting out with, well, where's that angle? Well, we start right here, always at that positive x-axis, and our terminal side is right here. So here is our angle, and that angle happens to be 3 pi over 2 radians. So if we think about this in terms of every radius has an exact length of 1, and we take a look at the fact that we started right in the middle at 0, 0, if we come down to the point here where it intersects, this intersection value has an x value of 0 because we didn't move left or right at all, and we went down 1, so that would be 0, -1. So now we have the values that we need. We know that x is equal to 0, we know that y is equal to -1, and we know, because it's a unit circle, that r is going to be equal to 1. So in all of these, we can figure this out relatively quickly. So the first two are going to be the easiest because they're given in that point, and then the rest of them are offshoots of that. Okay, so in the first example that we have here, the sine we said was always going to be equal to the y value. So the sine of 3 pi over 2 is -1. The cosine of 3/2 pi radians would be equal to 0. Now the tangent is a little bit more unique because the tangent still is going to be y over x, but in this case that brings us to -1 over 0. So in this case the tangent ends up being undefined. Anytime you're dealing in a unit circle on a quadrantal angle and you come up with a 0 in the denominator, it's simply undefined. So now we take the reciprocals of these, thinking in terms of the radius being 1. Okay? So the next one that we would have would be the cosecant of 3/2 pi over 2, and that would be the reciprocal of 1 over -1, which would still be -1. Now the secant would be the reciprocal of 0 over 1, which would be 1 over 0, and again, like it did with the tangent, it becomes undefined. That 0, of course, coming from the x value in our original angle measure. And the last one, the cotangent of 3/2 pi would end up giving us the reciprocal of what was undefined before, which was 0 over -1, which would simply be 0. So there's how you'd find these values in a unit circle. The next page that I have here for you are commonly used trig values, all found in the first quadrant. The reason that these are given, and they're only given in the first quadrant, is because to find any other angle measure outside of it, we're going to use reference angles. So now everything that we've seen in the last couple of lessons are going to start to come forward on this and be able to use them all together. So this would be a chart that would certainly be worth memorizing, especially if you're going to be taking pre-calc next year. So the last thing I have for you here for today is, how are we going to find these trigonometric values given an angle measure that doesn't happen to be in the first quadrant? Well, there are 3 steps to this process that we're going to take a look at. Step number 1, we're going to find the reference angle. Step number 2, we're going to evaluate the trigonometric function for that reference angle. And that's exactly what that chart was talking about on the previous screen. And then the third thing we're going to do is, using the chart that we see here to the right, we're going to determine the sine of the trigonometric function value given the quadrant that the terminal side ends up in. Okay? So let's take a look at these examples and see exactly how this is going to go. Okay, so we have 2 values. The first one is the sine of -225 degrees. So step number one that we are going to take a look at is what would be the reference angle for that. Now you can do this mental math, you can do this paper and pencil. I'm just going to draw it so you can see it. So if we start with negative 225 degrees, remember that goes in a clockwise fashion and it ends up giving us a terminal side right here in quadrant 2. So there's the negative 225 degrees. So what we're looking for is what's its reference angle? Well, how many degrees back to the negative x-axis is it? And the answer is it's 45 degrees. So the reference angle for this given situation is 45 degrees. So step number 2 is we have to figure out then what is the sine of 45 degrees. Now if we take a look at that previous chart, the one that was in the notes on the previous screen, we would see that the sine of 45 degrees is equal to the square root of 2 over 2. And now the third step in this process is to figure out what is the correct sign for the sine of negative 225 degrees based on the fact that the terminal side is in quadrant 2. So if we take a look up here, notice it says that the sine of theta in quadrant 2 would have to be positive. So in this case, our final answer for this would be the sine of negative 225 degrees is equal to positive square root of 2 over 2. And that's all there is to it. So let's try one over here. Same type of situation, but in this case, we're going to be dealing in radians instead of degrees. And the reason I want to do one of both is to show you that they're actually exactly the same. So in this case, if we go 5/3 pi, we take a look at that, 5/3 pi would put us right down here in quadrant 4. So there is 5/3 pi for our radian measure. So how much further would we have to go in order to find that reference angle? Well, how far is it from 5/3 pi to 2 pi? The answer in this case, what's left would be 1/3 pi. So our reference angle in this case would be 1/3 pi. So step number 2 is we are looking for what is the cotangent of 1/3 pi. And again, if you look at that chart that I gave you on the previous screen, the cotangent of 1/3 pi is the cube root of 3 over 3. So now the last thing that we have to do is we have to look up at our handy dandy chart here. It says in quadrant 4, the cotangent of any angle measure is going to be negative. So in this case, our final answer would be the exact trigonometric value of the cotangent of 5/3 pi would be negative square root of 3 over 3. So now, ladies and gentlemen, we've kind of brought together the last 3 lessons into one concise way of finding that exact trigonometric value. All right, ladies and gentlemen, that is all I've got for you for today. Again, if you do have any questions, please make sure you let me know. I'll work through your practice problems and go through anything that we have there next time that we meet. And as always, ladies and gentlemen, stay safe, stay healthy, and Lord's blessings on your day. We'll talk to you soon.